Hello. Our last presentation in our lift station and force main panel is Andy Dettmer with RJN Group speaking about force main management. Andy?
Thanks, Zach. Zach mentioned my presentation is Force Main Management. I'll be talking about how to help you have confident budgeting for your capital improvement program and operations and maintenance budget. So before we get started, I wanted to quickly recap some of the benefits of having a proactive approach to your force main management. Really four main areas. The first one is often on people's mind, trying to increase our confidence that we won't have SSOs related to force mains and these large breaks or failures we sometimes have. Second of all is to reduce the odor complaints that we often get from our customers. We'll talk about some of the sources of that. And third, reducing pumping costs. A lot of times our force mains, due to one reason or another, have increased restrictions in the line, and that can increase our pumping costs as well as wear our pumps out faster. And then finally, the last benefit is how do we have this confident budgeting for putting a plan moving forward. There's several challenges related to force main inspection. The first one is some of the limitations that surround the different inspection technologies that are out there. There's a lot of new and exciting stuff on the market right now. And then there's some old tried and true methods. And the main takeaway here is there's not one silver bullet. And we can talk a little bit more about technology later on. The second challenge is the repair and rehabilitation technologies also have limitations. These are improving dramatically. There's some new standards coming out very soon and some new techniques that show some promise. But we need to know where to apply these. Third, the lack of redundancy. Most force mains were not installed with a second force main in parallel, and so being able to get in these mains can be a real challenge. And that's related to the fourth one here is lack of access points and flow control. Most of the time, access points were not built into our force mains. They often were not built for inspection. And even if we can get tools in the line, some tools require certain flow rates, and sometimes we do or do not have the ability to adjust those flows. So that can also present different challenges that we can overcome. And then finally, what is the total project cost and risk? A lot of times we're just focused on technology and what that's going to give us, but we really need to think about the end and what we're going to do with that information, and helps us make better decisions before we approach the project. One of the places I like to start is to think about how can my force main fail? And this is a fundamental question related to failure modes, and it goes beyond just the pipe wall itself. There's four main categories for failures related to force mains, and everybody defines failure just a little differently. But the first one is related to insufficient capacity. The second one is related to odor. Third is leaks, and then fourth is breaks. And I make a distinction between breaks and leaks that is a bit nuanced, but the American Water Works Association defines breaks as a complete failure of the line such that the line can no longer function. So this would be a very large SSO, and you're no longer discharging to the destination. Whereas a leak might just be a simple drip. It still can be classified as an SSO, but it's a smaller issue that we're going to treat a little differently, as you'll see here in a second, related to the types of technology, which technology gets applied. But breaks within force mains can further be broken down into three areas. So we'll break down this black box, breaks, and expand it to these three additional boxes in black: external loading, internal pressure, and pipe wall weakening. So taking one step back, we'll start on the left-hand side, insufficient capacity. What are the different ways that contribute to insufficient capacity? The first is gas pockets. We see this often in force mains, creating a flow restriction, and then also contributing to potential corrosion if it's a non-plastic pipe. The second is other blockages. We see a lot of these are very low, And then finally, is the pipe too small? If this is an under capacity pipeline, then probably needs to be flagged for upsizing, and further inspection may not be warranted. Different contributors to odor is one is poor design, depending on the retention time, or depending on where the air valves are actually placed. We see a lot of times air valves have just simply not been maintained. A lot of our O&M budgets are stretched thin, and sometimes some quick repairs or replacements to air valves can help address these odor concerns. With leaks, there's AWWA classifies leaks into 3 areas: leaks that surface, leaks that don't surface, and then leaks that are undetectable. And we'll dig into each of these in a little bit more detail in the subsequent presentation, but I wanted to identify that each one of these we're gonna find a little bit differently. External loading has a couple of different issues. One, the pipeline may have been designed improperly originally, or perhaps it was installed incorrectly. Sometimes we see pipes of different pressure class or depth, bury depths, being installed in the wrong place, or perhaps the pipe was under designed originally. So taking a look at the wall can help us establish that. Sometimes we have increased overburden. Essentially, this is when developers or Department of Transportation adds additional fill over the top of our pipes. This can exceed the dead load carrying capacity of that pipe and cause the pipe to become out of round and increase stress and ultimately lead to failure. So that's something we can look at generally pretty easily. Internal pressure has a few other contributors. Poor design. Again, this could be a pipe wall design issue or a pump issue. We've seen several different surge events within force mains. Sometimes these can be resolved very quickly due to pump issues, operational issues, or check valve issues. And then finally, weakening of the pipe wall. Sometimes in force mains, they were designed for future flows, and the pipe is just over overcapacity. And in this situation, if the pipe is not flowing full in certain areas and it is susceptible to internal corrosion, then we can get rapid deterioration of the pipe wall since it's oversized. And then finally, with pipe wall weakening, we have detectable thickness, detectable pipe wall weakening, and we have undetectable based on the limitations of today's technology. And we'll dive into more detail about specific technologies and how we use those related to finding weak pipe walls. Before we jump into inspection, I wanted to discuss the value of what we call a find and fix approach and why that should be weighed against replacement. When we say find and fix, essentially we're saying there's a process of inspection and condition assessment to formulate recommendations on how to do point repairs or rehabilitation. And that entire process can be very involved depending on different variables. And in some cases, the cost of the find and fix can be substantially higher than you think going into it. And so we want to think about the total cost and consider, in some cases, putting in a parallel force main or replacing the force main in place. So when I say total cost, these are some of the elements that we want to make sure we consider on the front end. And we divide these into 4 categories. The first is inspection preparation. There's different costs associated with that. Second is inspection support. Third is assessment. This includes the inspection field work as well as the engineering analysis to determine what should be done based on that information and the recommendations for repair, rehabilitation, and then the actual construction that follows. So in the first one, for inspection preparation, looking at the valves, what excavations are required to get the tools in and out of the pipe or to gather information about the outside of the pipe, looking at access points, and then in some cases, cleaning the main so that you get an accurate inspection data. And then for inspection support, Somebody needs to operate the pumps and manipulate flows. We prefer that the utility do that, but sometimes there can be a good amount of value in the planning of those efforts, whether or not the pipe can be shut down or dewatered, and then dealing with issues of opening and closing flanges, and as well as traffic control during the inspection field work. Then for the inspection and assessment work itself, we're looking at leaks, deciding whether to do a structural inspection using electromagnetics or acoustics or other technologies to look at the pipe wall itself, weighing the cost and the benefit of that, as well as the follow-up verification to make sure that we're actually document what we think we found. Some of these tools are pretty new and require a verification and calibration after the initial inspection's done, and we want to make sure that we include the cost of that in the total cost analysis. And then finally, for the repair and rehabilitation work, we need to consider what is the risk of repeat failures if we don't rehab or replace the entire pipeline, and there's portions that continue to deteriorate. What is the risk of that repeat failure, and what kind of impact is that going to have to the utility? The subsequent shutdown to facilitate repairs and rehab, as well as the design and construction management associated with doing that work. So when I say we need to weigh this against replacement, one example would be if you had a replacement force main that would cost $10 million to replace the entire alignment, then our find and fix really shouldn't cost more than $1 to $2 million. This is essentially 10 to 20% of replacement, and each utility may have a different hurdle rate, but these are some of the common rates that I've seen in the last 15 years in the industry. So with that, I'd be happy to open it up with questions. Thank you.
Thank you, Andy. And that concludes our panel discussion on lift stations and force mains. If you have any questions regarding any of the topics, please feel free to reach out to any of the speakers or your RJN contact, project manager, or client manager. Thank you for listening.